In this video, we are going to be taking addition rule for probability. Now, the first thing I would like to do is to give you the rule, then I explain it, then we take examples. Is that okay? So let's have the rule. When two events A and B are mutually exclusive. Now, what does it mean for an event to be mutually exclusive? It means that the two events cannot occur at the same time. For example, we can't have night and day at the same time. These two events are mutually exclusive. If we have night, then we don't have day. If we have day, then we don't have night. Another example is if I toss a fair coin. Now, there are two possibilities. I can either have head or tail. But I can't have head and tail at the same time. It means that events of having head and the event of having tail are mutually exclusive. The two events cannot occur at the same time. So let's get back to the rule. When two events A and B are mutually exclusive, the probability that A or B will occur is the sum of the probability of each event. Now, this is like a kind of real deep explanation of what happens, but if we want to make it in a simplistic way, we are going to have the probability of A or B equals to probability of A plus probability of B. It means that in probability, at least at this stage, when you see OR, it implies addition. Do you understand? Anytime you see OR, it implies addition. Can we take examples? So we have this example. The probability that Idris and Catherine will pass an exam is 1/4 and 2/3 respectively. What's the probability that either Idris or Catherine will pass the exam? Now, can we solve this? So from the question, we have the probability that Idris will pass is 1/4. The probability that Catherine will pass is 2/3. So we can have probability that Idris passes equals to 1/4. We are given the probability. And then we have probability that Catherine passes equals to 2/3. Now we are asked what's the probability that either Idris or Catherine pass. So we have probability that Idris or Catherine pass. That will be equals to, what's the probability that Idris will pass? 1/4. Or symbolizes plus. What's the probability that Catherine will pass? 2/3. Do you understand? So probability that Idris or Catherine will pass is probability that Idris will pass plus probability that Catherine will pass. So we find the LCM. LCM of 4 and 3 is 12. 12 divided by 4 is 3. 3 times 1 is 3 plus 12 divided by 3 is 4. 4 times 2 is 8. So we have 3 plus 8 all over 12. 3 plus 8 is 11. So we have 11/12 as our answer. So the probability that Idris or Catherine will pass the examination is 11/12. Do you understand? Let's take another example. So we have a zoo contains 30 zebras, 25 tigers and 50 monkeys. If two animals are picked at random, what's the probability that it's either a tiger or a monkey? Now, if you look in this case, we're not given the probability of picking a zebra. Neither were we given the probability of picking a tiger, nor the probability of picking a monkey. Instead, we're told how many zebras and tigers and monkeys we have in the zoo. So the first thing we need to do is to find the probability of picking a zebra, a tiger, and a monkey. That is when we can now solve the question we are asked. Can we do that? So we have number of zebras equals to 30, number of tigers equals to 25, then lastly number of monkeys equals to 50. Now remember, the last thing we need to do is to add them up. So 30 plus 25 is 55. 55 plus 50 is 105. So total is 105. Do you understand this? So now we need to find what's the probability of picking a zebra. That will be, how many zebras do we have? 30 all over. What's the total number of animals? 105. Do you understand this? 5 in 30 is 6. 5 in 10 is 2. 5 in 5 is 1. 3 in 6 is 2. 3 in 21 is 7. So we have equals to 2 over 7. Does this make sense? So we go to the next. Probability of picking a tiger. How many tigers do we have? 25 all over. What's the total number of animals? 105. 5 in 25 is 5. 5 in 10 is 2. 5 in 5 is 1. So we have 5 over 21. Alright, so we do the last one. Probability of picking a monkey. So probability of monkey. How many monkeys do we have? 50 all over. What's the total number of animals? 105. 5 here will give us 10. 5 in 10 is 2. 5 in 5 is 1. So we have 10 over 21. Do you understand? Now we have the probability for zebra, probability for tiger, and probability of monkey. Now we can now solve the question. If two animals are picked at random, what's the probability that it's either a tiger or a monkey? So we have probability of tiger or monkey. Now to get this, it will be equals to probability of tiger, or symbolizes what? Plus probability of monkey. Do you understand this? So we have equals to probability of tiger, we got it as 5 over 21. So we have 5 over 21 plus probability of monkey, we got it as 10 over 21. Does this make sense? So find the LCM. Can we do it by the side here? So we have 5 over 21 plus 10 over 21. We find the LCM, 21. 21 divided by 21 is 1. 1 times 5 is 5. Plus 21 divided by 21 is 1. 1 times 10 is 10. So we have equals to 5 plus 10 is 15 all over 21. 3 can go. We have 3 in 15 is 5. 3 in 21 is 7. So our answer is 5 over 7. Do you understand? So the probability that it's either a tiger or a monkey that is picked equals to 5 over 7. Now don't forget what we did. If you were given the probability straight up in the question, you just add. But if not, you have to find the probability first before you add. I hope you understand. Now can we twist the question a bit? I want to show and explain something to you. So we have, what is the probability that it is neither a tiger nor a monkey? Now remember, we found the probability of now this is simple, because probability that is neither tiger nor monkey is simply equals to 1 minus probability that it's either a tiger or monkey. Does this make sense? So we'll be having equals to 1 minus. Remember, we got probability of tiger or monkey to be 5 over 7. So we have 1 minus 5 over 7. We find the LCM. 7 divided by 1 is 7. 7 times 1 is 7. minus 7 divided by 7 is 1. 1 times 5 is 5. 7 minus 5 is 2 over 7. Does that make sense? Now, if you think about it deeply, the probability that is neither tiger nor monkey is actually the probability that is a zebra. Does that make sense? If it's not a tiger and it's not a monkey, then it's a zebra. And what did we get for probability of picking a zebra? 2 over 7. Can you see that? It confirms our answer. So I hope you understand that when you have probability of an event occurring, let's say A, or probability of another event occurring B, as long as they are mutually exclusive, it will be probability of A plus probability of B. And when we have probability of two events, neither of them occurring, all we need to do is 1 minus probability of either of them occurring. I hope you understand.